All right, so 2.6 talks about skewness and the mean, median, and mode. All right, so if we have the data set 4 all the way up through 10, we can have the histogram that describes this data set. Now this one has a very symmetrical design, and if the data is symmetrical, that means that for this distribution, that the mean and the median are the same. So I'm going to slide this down just a little bit. Because our histogram is symmetrical, or if it was perfectly symmetrical, the mean and the median would be the same. All right, so when we look at this histogram, it almost looks like the right side got chopped off and the data has been pulled to the left. This makes it skewed left, right? So this is an example of data that has been skewed left, or skewed left. You can think of it almost as if this data got pulled this direction. Okay, now with this data set, this has been skewed to the right. So if we look at that data, it looks like the data has been pulled to the right. Okay, so this is an example of skewed right. All right, this summarizes what's happening with those central measures of the data. And this is important because sometimes they'll ask you questions about where the mean and the median and the mode relate to each other, if it's skewed left or skewed right. So to summarize, generally if the distribution is skewed left, the mean is less than the median, which is often less than the mode. If the distribution is skewed to the right, the mode is often less than the median, which is less than the mean. You can almost think about it as the mean is dragging or pulling the data in that direction.